Okay, well, I'm here to help you out with the fourth video topic, which is called diagramming electrochemical cells, diagramming cells. And this is fairly straightforward. The idea is that we have some sort of picture or maybe a physical apparatus in front of you, and we'd like to be able to sort of describe this whole cell without having to write this much. Okay, so a diagram of a cell is a shorthand for a picture like this. And the way it generally goes is something like this. On the left-hand side, we will write things related to the anode, and on the right-hand side, we write things related to the cathode. And, there's this salt bridge, or the porous separator that's there. I like to start off with the porous separator and just kind of work my way back this way. And so if that's the case, then what you want to know is that porous separator is generally indicated by two vertical lines. So I'm going to write two vertical lines there, okay? And now the next thing is, what is the porous separator connected to? Well, it's connected to these electrolytes. So I'm going to write the electrolytes there, and so I'm going to say on the left, I can see it's something X, okay, aqueous. And on the right, I can see that it's Y plus aqueous. Okay, and now I'm continuing to work my way up here. I notice that X aqueous is connected to a metal electrode, X solid. So whenever we have what's called a phase boundary, and that is a phase boundary is going from liquid to solid, or perhaps to gas, but in this case it's liquid to solid, that corresponds to just a single vertical line. So that would be going from here to here, and now I get to write X, S, okay, and on the right, same thing here, the Y electrolyte is connected to solid Y, so that would be YS, okay? And this would be the diagram for that cell. So here's what you might want to try to do. Let's suppose instead of X, I have copper 2+, okay, and it's connected to a copper electrode, so that would be copper. Then I've got, let's say silver over here, Ag. That's the electrolyte, and then I have solid silver over here. So it's pretty straightforward, I think. How would you go ahead and make the diagram of this cell? Okay, well, I'm just going to do the same thing here. It's pretty straightforward. I can see it's copper 2+ on the left-hand side of the salt bridge. So there's copper 2+, aqueous. And then on the right, I have Ag+, also aqueous. And now connected to the copper 2+ is a copper electrode, Cu, solid. And connected to the silver electrolyte, I've got Ag+, solid. And we're done, okay? Now one more little twist on this, and it goes something like this. On the left, I know I have the anode, and we know that what's going on if we have an anode is that chunks of this solid, or little bits of the solid, are getting eroded and turning into copper 2+. So that's fine. I mean, what that means is that whatever this anode is, it must be the same element that's appearing as the electrolyte, because that's where the electrolyte comes from. But here it's different. At the cathode it's different, because what's happening, of course, is that electrons are coming down here and attaching themselves to the electrolyte and plating themselves onto here, right? So what that means is that one doesn't even have to have a silver electrode if that is the cathode. It could have been anything, okay? So I'll do one more little twist. Quite often people use a platinum electrode at the cathode. So how would that change this cell diagram? Okay, I think everything is pretty much the same. I've got copper solid, phase boundary, and now I'm working from this way, solid copper going to phase boundary to copper 2 plus aqueous. Okay, and now I'm going to the salt bridge to Ag plus aqueous, and now phase boundary up to our platinum solid cathode. Yeah. All right, that's pretty much it. The one very last thing that I just wanted to mention is that it's assumed, unless sometimes you might want to actually specify what the concentrations are. So in this case, you see we've left it sort of ambiguous here. We haven't said what the concentrations are. If I knew that I had 1 molar or 0.1 molar copper, I would have put that in parentheses instead of just aqueous, and likewise for the silver. Okay.